Hey guys, Mr. Milson here. Today we're looking at quadrilaterals in the coordinate plane notes. At the end of this video, you should be able to find the slope, distance, and midpoint between 2 points, and you should be able to use the properties of special quadrilaterals to identify the coordinates of special points. Okay, so this lesson really lays the groundwork for tomorrow's lesson. So make sure that you understand what's happening and what's going on today, because really what we're doing now is we're taking what we learned from algebra and using algebra and making it just a tiny bit more abstract with the use of variables rather than integers. Okay, and so let's go through it here. Algebra, you might be asked to find the slope between 7, -2 and 5, 1. Remember, slope is y2 minus y1 over x2 minus x1. Rise over run, all that good stuff. Okay, and so if we were doing this, we'd say 1 minus 7. So if we were doing this, we'd say 1 minus -2 plus 2 over 5 minus 7. So 1 minus -2, 3. 5 minus 7, -2. And so we'd have our slope as -3 over 2, or -3/2. Okay. Now, if we were asked to find the slope of abstract placement of 3AB and 2A0, we could still do that. It's the same thing. Y2, 0, minus Y1, B, over X2, 2A, minus X1, 3A. And so I'd have -B over -A, and that negative over negative becomes positive, B over A. Okay, so doing the same thing, just with some variables in place of where we typically see integers. Number 2, distance. Okay, remember your distance formula. Distance is the square root of the difference of x's squared plus the difference of y's squared. Okay, and so when we use that with numerals and integers, let's just say that better. I could say, okay, my x is 3, other x is -1, so I'm going to say +1 squared plus 4 minus 7 squared. And so 3 plus 1 is 4 squared. 4 minus 7 is -3 squared. So that's 16 plus 9, or 25. So my distance here is the square root of 25, which is 5. Okay, just plugging in numbers, simplifying. Okay. Here we can do the same thing with variables, even though it looks a lot funkier, especially this thing that has an expression here of a plus b. We can do the same thing. So our distance is a plus b minus b squared plus 2c minus c squared. Now, once we simplify this, because it looks a little intimidating right now, but once we simplify inside these parentheses before we square it, we'll see that this turns into a squared. 2c minus c is c squared. And we're done here. Okay, a lot of people will fall into, oh, we have a square root and a square, cancel them out, but with this expression, we cannot do that. This is as simple as we get. So our answer here is the square root of a squared plus c squared. Okay. There we go. So if we're asked to find the distance using variables, we can do that as well. Finding midpoint. Remember that midpoint is basically when we're trying to find the midpoint, we had to find kind of set up two problems. It's the average of the x's and average of the y's. And then we use that in our coordinate, right? Mid x, mid y. Okay, and so when we're asked to find the midpoint of these 2 points, 5, -2, and 1, 3, we'd say, okay, what's the midpoint of that? We'd say 5 plus 1 over 2. 6 over 2 is 3. So our x's is 3. -2 plus 3 over 2. And that gives us 1 over 2, or 1/2. Okay, so we find our x midpoint to be 3, our y midpoint to be 1/2, and so our midpoint is going to be 3, 1/2. Okay. We can do the same thing if we're given variables. Our x's at -b plus -b. I don't like saying plus negative. So if I have -b minus b over 2, and that gives me -2b over 2, which I can divide, and that just gives me -b. So my x coordinate is -b. For my y's, I have 2c plus -2c, or minus 2c over 2. 2c minus 2c gives me 0 over 2, which is just 0. And so there we have it. Okay, so using our old algebra skills to and converting them basically to using them a little bit more abstractly here. All right, now when I say you're going to apply it, this is what I mean. So finding coordinates, we're given a quadrilateral and a coordinate plane, and asked to find the say placement, the coordinates of these points, given some information about the quadrilateral. So it says the figure is a rectangle. Give the coordinates of WZ without using any new variables. Then find the slope, distance, and midpoint of WZ. So without giving any new variables, first of all, this is on the origin, so we don't really need a new variable. These are numbers here. Origin 0, 0, that's how coordinate planes work. So I have O already listed, 2B, 2H is our height there. Okay, the way rectangles work should help us out a little bit in the sense that I know that my x coordinate for W is 0. Okay, didn't go left or right, still on our y-axis. Okay. In a rectangle, we know that opposite sides are congruent to each other. So since this goes up, looking at our coordinate, it goes up 2h. So on the other side, it should go up 2h. Our W coordinate is 2h. Looking at z, it's still on the x-axis. Okay, so our our y coordinate for z is 0. Hasn't gone up or down any. Okay, the same kind of logic that we use for the height of W, we can use for our displacement in z. How far over did it have to go? Well, it should be the same far over as this point. How far over is this point? 2b. Okay, or not 2b, as William Shakespeare would say. All right, sorry. I needed to say that. Okay, all right. So now we found those 2 points. The coordinate for W is 0, 2h. The coordinate for Z is 2b, 0. Now they ask us for the slope of this point. So here, let's find the slope. The slope of this line between WZ. Okay, so since we have these 2 points, let's do y2, 0, minus y1, 2h, over x2, 2b, minus x1, 0. Okay, and so I have negative 2h over 2b, or over 2b. Said it like I had more to say. Okay, And looking at this, I want to simplify if I can. There's a 2 that fits into both of these. And so the slope just becomes negative h over b. Okay, switching it up as not to be confused. Here's our distance. They want us to find the distance between WZ. So distance formula, just plugging that in. The difference of the x's, so 2b minus 0 squared plus the difference of the y's, 0 minus 2h squared. Okay, so that will give us 2b squared plus negative 2h squared, still the square root, and so that gives us 4b squared plus 4h squared. And there we go, that's our distance. The square root of 4b squared plus 4h squared. Okay, and then our midpoint, they're asking us for, remember that's just the average of the x's, so 2b plus 0 over 2, the average of the y's, 2h plus 0 over 2, and that's 2b over 2, which is b, and 2h over 2, which is h. So our midpoint would be BH, and we can check that out on our point if we look at see, I'm terrible with these straight lines. All right, there we go. That's a little bit better. If we think about BH and where that would be, as soon as my eraser starts responding, then we could say, okay, well, that midpoint should be somewhere over here, the middle of this, And yeah, if we said it went over 2b, it should move over b, half of it. If it went up 2h, it should go up just h. So we think, yeah, BH would be a pretty good spot for that midpoint. Okay, is B 7? Is B 2.6? I don't know, but whatever B is, here's our midpoint, whatever that value is. Okay, so there we go. We've applied it to this figure. All right. Last one here, it says the figure is a parallelogram. Find the coordinates of t and find the slope, distance, and midpoints of ST. Okay. So again, this time they asked us to find the coordinates of t and not of S, even though they didn't give us the coordinates of S, but we need to know that S is on the origin, it's 0, 0. Okay. Now, always important for us to establish what figure this is, type of figure it is. It tells us it's a parallelogram, and that's going to be important for us to look at as we talk about what's happening. So because it's a parallelogram, there's a couple things that I know, and I know that the opposite sides are congruent and the opposite sides are parallel. When we say parallel, what we need to be thinking of is that means our slope is the same. Slope or rise over run. I'm going to establish what my rise over run is here. From S to this point, how far up do I go? Okay, well, I can look at the D, the Y coordinate, or the Y, coordinate here. It goes from 0 to D, which is the increase of D. How far over do I go? From 0 to C, increase of C. Because these two lines are parallel, I know that this is the same here. It goes up D as much and it goes over C. So plus D plus C. So for T, since I start at B for my X coordinate, or let's start with the Y coordinate, it's a little bit easier. For my Y coordinate, I started at 0. I go up D. 0 plus D is D. For my X coordinate, I start at B. I go over plus C. B plus C will be written as B plus C. No, we're not adding a new variable. There's no way for us to condense that or simplify that any further. So we just say this coordinate then is B plus C, whatever that might be, D. And so now going through finding the slope between ST, right? Since S is 0, makes it a little bit easier. So I have D minus 0 over B plus C minus 0. And so that slope should just be D over B plus C. Okay. Distance here gets a little bit more. Do some different colors just like I did last time. Distance gets a little bit more involved. Distance. We've got the x coordinate, which is B plus C minus 0 squared plus D minus 0 squared. Okay. So B plus C squared plus D squared, which the D squared part is pretty simple. It's just D squared. The B plus C squared part makes us have to go and actually do that out. B plus C times B plus C, which gives us B squared plus BC plus BC plus C squared. So we get that B squared plus 2BC plus C squared plus D squared. Woo. All right, there we go. All right, so yeah, not the prettiest answer, but an answer nonetheless. So B squared plus 2BC plus C squared plus D squared. All right, let's go back to midpoint. That should be easier, right? Hopefully. And midpoint. So midpoint will be the average of the x's, which the x coordinate for our t, b plus c. The x point for s is 0. Okay, so b plus c over 2. Not really a better way to write that than b plus c over 2. And our y's would be d plus 0 over 2. 0 goes away. So d over 2. So b plus c over 2, d over 2. Midpoint. All right. So hopefully you're good with that and you get past using those variables and these otherwise familiar formulas. See ya.